Okay, so now what is this chapter really going to be all about? Okay, so in nervous coordination, guys, what are we first going to see? We are going to see what is your brain. Okay, so we are going to see first what is the nervous system, what are the different parts of the nervous system. Then we are going to talk about the brain. Then going to talk about your spinal cord. Then we are going to talk about, like, what are the different types of your nervous system, like your peripheral nervous system, what are the ones that are going to be included inside of it, and so on and so forth. So, guys, this is how the chapter is going to move about. Okay, but now let's try to start with the initial part and let's try to see how is your nervous system, what is it going to be made up of, and what are the different types of cells seen in your nervous system. Guys, generally when we talk about nervous system, we always think of like only the neurons, right? But now your brain is not only made up of your neurons, or your spinal cord is not only made up of neurons, but there are going to be some other cells which are also going to be present alongside those neurons. Okay, so let's try to see, guys, what is this? How is it going to be like? Okay. Okay, so now, first of all, guys, when we talk about nervous system, what is the basic job of nervous system? Guys, the basic job of nervous system is sensory perception. Okay, sensory perception meaning this is the one which is going to help you sense different things. Okay, so for example, your eyes can help you visualize things, your ears can help you hear, the nose can help you smell, tongue can help you taste, and the skin can help you touch and sense that way. So the basic job is sensory perception. And whenever you have the sensory perception, there has to be some kind of a response. So, for example, guys, let's say I take a stone and I throw at you. The moment I throw the stone at you, you're not just going to stand out over there, thinking that, oh, sir has thrown a stone at me, I will get it on my face. No, immediately your action would be to duck or to dodge. That ducking or dodging is called as your response. Okay, so sensory perception and response. But now, when we talk about the nervous system, who is the smallest unit of your nervous system? The smallest unit, that is the basic unit, this is nothing but your neuron. Okay, or what is the other name that you will call this thing? We call this thing as your nerve cell. However, remember, guys, neuron is a better term, nerve cell is an old term. Okay, so always stick to neuron. Sure. But now let's try to see what are the different types of cells that are going to be present. Okay, so we have a nervous system. Okay, and this nervous system, first of all, we are going to have the neurons or the nerve cell. Okay, so and that is the first thing that is going to be seen. So let's say the neurons, they are going to be somewhat like this. It has a star-shaped body. Okay, and then you are going to see that it has these long axon. Basically, this is an axon. And then here, from here, these are your, basically this is called as a cyton. Then we have the dendron, we have the dendrites, like this. Okay, so this is how it is going to really appear, the neuron. Okay, fine. But now, guys, after the neuron, you are going to see something very important. See, your entire brain, it is not going to be made up of just your neurons. Okay, so apart from this, there are going to be some packing cells. Packing cells, or cells which are going to just fill in the void spaces. Who are these? We have microglial cells. We have microglial cells, or we call them as neuroglial cells, or we also call them as your neuroglia. Okay, neuroglia, or we also call them as just glial cells. Okay, guys, many names for these things. Okay, or we also call them as astrocytes, or we also call them as oligodendrocytes. Okay, so all these are like, see, astrocytes, oligodendrocytes, these are like different cells actually. They are going to be seen in your brain. Now, how is it going to be? Let's try to see. So guys, let's imagine this is your brain. Okay, now in your brain, let me just show you. Okay, chalo, these are your, your neurons. Okay, so let's imagine these are your neurons. Now, it is not so that your neurons are going to be present everywhere. Okay, there are going to be some spaces in between them. Okay, so let's say, so these are how your neurons are going to be. But in between the neurons, okay, now you are going to be seeing that these spaces are filled. See, these spaces are filled with cells, and these are nothing but your microglial cells or your neuroglial cells. Okay, so these are those cells present. Okay, let's try to see the third one, guys. And the third one we are going to encounter, these are called as ependymal cells. Okay, okay, now where are we really going to see these ependymal cells? Okay, so guys, you are going to have your brain. Okay, the brain is something of this sort. Okay, inside the brain, guys, there are going to be some empty spaces. Okay, empty spaces meaning they are going to be hollow spaces kind of thing, guys. Those hollow spaces, we call them as your ventricles. Okay, so these are some ventricles I'm showing you. Okay, so these are ventricles. Okay, we are going to talk about this thing in detail, guys. Okay, a little later. Okay, these are known as ventricles. But guys, these ventricles, they are now going to be lined. Okay, like this. These ventricles, they are now going to be lined by your ependymal cells. And these ependymal cells, what are they also going to help in producing? They help in producing your CSF, cerebrospinal fluid. Okay, so that is another thing. And lastly, guys, okay, last thing out over here, we are going to have neurosecretory cells of the brain. Okay, so this is the last but most important one. And guys, we have already talked about these neurosecretory cells. I hope you remember this. Okay, so neurosecretory cells, guys, where are we talked about? See, if you remember, we had said we have the hypothalamus. And from your hypothalamus, from the base of the hypothalamus, you are going to have the pituitary hanging out over here, right? So we said this was your pituitary, this was your anterior pituitary, this was your posterior pituitary. But guys, what did we say? In the case of your posterior pituitary, does the posterior pituitary produce hormones of its own? No, it is just going to store the hormones which are coming from the the cells present in the hypothalamus. So guys, which were those cells? These were nothing but your the neurosecretory cells, guys. So these were like this. And then ultimately, what had we said, guys? We had said that these are going to end into your Herring's bodies. If you remember, guys, and Herring's bodies, they are going to store the hormones, okay? And then they are going to release it as and when required. So these are our neurosecretory cells. So guys, these are the four things that are going to be present in your brain. Okay, chalo. Guys, just have a look. Just see if you guys are okay with this. Any doubts, anybody, guys? Ependymal cells, yes, ependymal cells help to produce your CSF. So there is some fluid which is running. We will see that a little later. Okay, the fluid that is like, a cerebrospinal fluid which runs through your spinal cord and your brain, that is produced by, the ependymal cells. Okay, everybody all right? Okay, chalo. Now let's try to move ahead, guys. Let's try to see some next important part. Okay. So, guys, now, we have already spoken of your hormonal coordination and we've talked about your, now we are talking about your nervous coordination. So, what we need to do is we need to find out what is the difference between your hormonal coordination and your nervous coordination. Because, see, guys, we had said earlier that in our body, coordination is going to be brought about by two things. Okay, so one, it is your hormonal coordination, and the second is your nervous coordination. Okay, hormonal coordination and nervous coordination. Okay, so first thing, guys, when we talk about hormonal coordination, who is going to be bringing about this hormonal coordination? This is going to be brought about by your hormones. Okay, so this is going to be with the help of your hormones. But now, if we look at nervous coordination, how is nervous coordination going to be brought about? Guys, this is going to be brought about by the release of your neurotransmitters. So in between your cells, guys, okay, in order to convey messages from one neuron to the other neuron, they release neurotransmitters. Okay, fine. Second thing. Okay, so how is this coordination really brought about? Okay, this is generally brought about by chemical means. So we say, it is brought about chemically. But now, when we talk about neurotransmitters, guys, the nervous coordination is brought about in neurotransmitters. But neurotransmitters, basically, this is going to be on the basis of two things, in the basis of electrical charge and on the lines of your chemical means also. So this is electrochemically. Okay, fine. Next thing, guys, when we talk about your hormonal coordination, the effect which is shown by hormonal coordination, the effect can be short term, meaning it can be for a little while or it can be long term. So short term or long term. And if we talk about your nervous coordination, guys, the effect, always remember, the effect is always going to be short term only. Why? Let's try to understand this thing, guys. Okay, so first thing, guys, when we talk about your hormones, okay, now the hormone may be produced, in a flash of a moment, meaning, and then it will work only for a little while, meaning it will do its job and it is immediately going to be broken down and removed from the body. There are going to be some hormones like that, but some hormones, guys, they are going to be present in your body. They will stay in your body for a little longer time, and they will continue to bring about their job for a larger period. Okay, so that is going to be long-term effect. But now, guys, let's say nervous coordination, it is always going to be very, very short term. For example, guys, let's imagine we have a mosquito. Okay, so let's say a mosquito has just sat on your hand and she has just bitten you. Okay, she has just bitten you. Okay, now, guys, what is your reaction going to be? So immediately you are going to, your brain is going to sense that, oh, something is poking. Immediately you need to just slap that mosquito. Guys, now the brain is going to send that impulse to your hand. And now what is the hand going to do? The hand is going to go and it is going to slap that mosquito. Yes, attack. Okay. So the hand is going to come and slap that mosquito, attack. But guys, how long is this thing going to happen? Like when you slap a mosquito, do you go, yeah, sat, 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 you keep on hitting at the same place over and over and over again? Or is it like, the Hindi serials, first you hit it in one direction, yeah, satak, then another direction, yeah, satak, then another angle, satak, then another angle, satak? No, right? It doesn't happen that way. You are going to slap only once and that's it. Okay, that's it. The job is done. So here, guys, when we talk about this, your entire process, okay, your entire process is actually short term. Okay, so this is not going to be long lasting at all. Very, very short term. Okay. Had it been long lasting, guys, then what would have happened? You have kept on slapping your hand even after the mosquito has gone. So it would continue to hit sat, 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 like that. But it doesn't happen that way. Okay. But then nervous coordination, okay, so, hormonal coordination. Guys, hormonal coordination is a very, very slow process. For example, guys, let's say suddenly the body's glucose levels have increased. Okay. So as the body's glucose levels have increased tremendously, guys, what will happen? That is going to alert the cells of the pancreas. The pancreas are then going to alert the islets of Langerhans. The islets of Langerhans are then going to alert the beta cells to produce insulin. Then insulin will be produced. Then it is going to be poured into the body. Then it is going to start acting on all the cells and then it will decrease the glucose levels. So guys, in order for this thing to happen, it requires certain time because every now and then you don't have ready-made hormones. They have to be made to order, right? So that is why this is going to be a slow process. But now, when we talk about nervous coordination, if you want to just slap the mosquito, are you going to wait for a long time? No, it's going to be sapat, instantaneous. So this is going to be a really, really fast process. This is a fast process. Okay. Next thing, guys, when we talk about your hormonal coordination, it can affect metabolism. It affects metabolism of the body. Okay, because we have different hormones. We have a thyroxine. Thyroxine is nothing but it is necessary for your metabolism. But then nervous coordination isn't going to affect metabolism. No, it cannot affect the metabolism at all. Okay, fine. Let's try to see another thing. Guys, your hormonal coordination, it affects growth. Nervous coordination, can it affect growth? Absolutely no. Guys, in your childhood times, you must have, seen these types of pranks. A person will take his hand and he will move over your head. And then he will say that, oh, आता तुझी हाइटच नाही वाढणार, आता तुझी हाइटच नाही वाढणार. But then, did it ever happen that way? That your height never increased? No, right? It did not happen that way. Or it was also said that if you go underneath, the legs of a person, then also your height won't increase. Did it happen that way? Absolutely no. Right, guys? There are other beliefs also. Like when you have that, Chandra Grahan, Surya Grahan, at that time, if you want to increase your height, the parents pull their babies from the opposite end, right? But then, if that is the case, guys, then the height, does it increase that way? Are you like a elastic band or a rubber band that okay, you pull it from both the sides and height बढ़ गया? No, guys, it doesn't work like that. Why? Because nervous coordination is not going to affect growth. Only your hormonal coordination affects growth. Okay, but now the last thing, guys, this is very, very important. Okay, hormonal coordination, it cannot be modified. It cannot be modified by previous experiences. Okay, and guys, this is very, very important. Very, very important. Okay, it cannot be modified by previous experiences. So my question to you guys is, okay, see, In your schools and all, okay, when you used to go to schools, okay, you must have had assemblies. Sometimes there used to be march past and all that thing, right? So some people used to stand in the hot sun and all, and they used to faint, right? Now guys, you must have seen that there might be some person who might be fainting again and again, again and again, again and again, right? It can happen. It used to happen that way, right? The same person fainting again and again. Now why does a person faint? A person faints because he has maybe very little amount of glucose running through his body. Why? Because suddenly the blood glucose levels drop down. The blood glucose levels drop down. Immediately you are going to feel that, oh, you feel palpitation, you feel, increase in your heartbeat, you feel perspiration. Then suddenly you feel that, your eyes have blackened out. Then you feel dizzy, ekdam, like, everything is moving besides you, like around and around and around and around. And then what? Chakkar. And then what? Kachak, you're going to fall down, faint, right? Now, guys, you tell me, when the blood glucose level is dropping low, what should the body do? Immediately, it should start producing glucagon, and glucagon should increase the blood glucose levels, right? But now, I told you, hormonal coordination is a slow process, so it doesn't happen that way immediately. In the meanwhile, guys, the blood glucose level dropped down so low that now you have very little blood glucose, and then you will fall down. Okay, now once this thing has happened, your body should learn from it. Okay, your body should learn from it that, oh, whenever you stand in hot sun or something happens like that, maybe your blood glucose levels are going to go down low and you'll faint. But the same person next time also faints, falls down. Third time also the same thing happens, falls down. Guys, how is this possible? How is this possible? Because your your hormonal system does not learn from previous experiences at all. That is why. Okay. But now let's try to see on the other side. When we talk about nervous coordination, guys, nervous coordination, this can be modified. Okay. For example, let's just try to see. My question to you guys, have you taken your finger and put into a socket, electric socket? I'm damn sure you must have done this once or twice. I'm sure of it, right? Or you must have taken your tongue and put it into the socket, in which, you were like, just curious. But guys, when you did that, okay, what will happen? You are going to get such a nice jolt of electricity, guys, and immediately you know for sure कि नहीं ये करने से shock लगता है. I am not going to do this anymore. After that, are you a crazy person that you keep on doing the same thing again and again? Absolutely no. Why? Because now your nervous system has known that, oh, if you do this thing, you are going to get a jolt of electricity. Let's say on the other side, guys. Okay, you are having a hot tawa. Okay, now, when you have this hot tawa, guys, when you touch the hot tawa, do you enjoy? Like, just no, right? You're not really going to like it because it's going to burn you, right? Now, next time, whenever you see a tawa, guys, a tawa which is kept on a gas, let's imagine, are you just going to take your hand and put on top of it, even whether it is cold, even whether it is hot? No, you will first maintain caution that no baba ye garam hai, isse chatka lag sakta hai. I'm not going to do that. So that is what we say, that nervous coordination can be modified. Let's try to move a slightly on a different angle, guys. Okay, my question to you is, like, guys, see, all of you must be using smartphones and all, like, right, every day. So you have the QWERTY keypad, right? Earlier, guys, do you remember the first time when you had a cell phone? Okay, at that time when you wanted to type something, guys, was it really easy? No, it was like you had to, like, literally take your pointer finger and used to go Q W E R T Y A S D F G H Z X C V D. Right? You had to actually literally go on finding out where which alphabet is present. But today, is it the same thing, guys? Is that the same thing? Like today, you have like mastered the skill of typing, guys. In fact, you don't even have to look at the screen. You can just type your message, thud, 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 put your phone under your desk, and then type whatever you want and fly the message to another person in the same room without even looking at the screen. Even that is possible, guys, right? So how is it happening? Because now your nervous system has known that, oh, these placements of letters are here only whenever you type. You have, you are going to type it properly, and you don't even really have to look. So nervous system has got modified. Okay, let me give you another example, last example. Guys, some of you must be playing musical instruments and all, right? So let's say you were playing the guitar. Okay, so when you started playing the guitar, now guitar has six strings: E, B, G, B, A, E. Okay, from the low to the high. Now, guys, when you started playing guitar, how did you play guitar? I'm damn sure how it goes. Okay, first you will take your right hand. Okay, if you're a righty, then okay. Then what are you going to do? You're going to take a plectrum, and then first it goes one string, ting, 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 ting. Okay, so guys, basically it goes one string at a time. Then what do you do? With the left hand, you are going to start playing the frets. Okay, then you get different tones, right? But then, guys, if you have played the guitar for like maybe like a year or a year and a half or 2 years, maybe, guys, today, do you really look at your finger position? Do you really look at your the which string are you playing? No, slowly you get used to it. Why? Because the nervous system has been modified. And I believe the same is with drums as well. Okay, so yes, so initially you have to have that role, you have to learn the role and all. So I'm not so well versed with drums, so but yeah, even piano, your keyboards, your harmonium, it works the same thing. Okay, basically it's the same thing with all the kinds of instruments. You first need to get the hang of it that way. Okay, so that is once again your nervous coordination, guys. Okay, everybody all right with this thing? Fine. Okay, so now guys, the next thing is we will just quickly talk about, okay, you want to see, have a look at it. Okay, chalo, just have a look at this, guys. See, this is the basic difference between hormonal and your nervous coordination. Okay, chalo, so let's move ahead. Okay, now the next thing that we're going to talk about is, guys, we are going to talk about a little bit of your evolution of nervous system. Okay, now evolution of nervous system, we'll just do this thing in a brief manner. Okay, evolution of nervous system. So guys, how does the nervous system start? Okay, so we said that we have like lower organism in some cases. For example, in the case of your sponges and all, the nervous system is not developed at all. But then slowly what happens as we started growing, meaning as we started evolving, let's say we went on to your hydra. Okay, so in the case of your hydra, guys, now what happened? We saw that, oh, in the case of hydra, now there was this entire nerve net. Okay, so it is not like your normal nervous system or something, but it is just like a nerve net kind of a thing, which is going to be present like this all throughout. So this is nothing but a nerve net. Okay, now what happened, guys? Now slowly, the organisms developed further. And as they develop further, now let's say we are into your worms. Okay. Now, in your worms, guys, what happened? Now, they had this brain kind of thing, and then we have your ganglionated nerve cords. Okay. So, this thing, so we have a ganglionated nerve cord like this. Slowly, guys, we still moved ahead. Let's say we talked about your cockroach. Okay, so let's imagine we have the cockroach. Once again, the same kind of situation, guys. But here, what are we going to see? We are going to see that, oh, here there is your the nerve ring. The nerve ring, and then we are going to have your double ventral ganglionated nerve cord. So like this. Then what happened, guys? Slowly, this thing all developed. And finally, we went on to your vertebrates. And in your vertebrates, guys, now ultimately, what did we see? The final evolution, we are going to have our brain, something like this. So this is how generally your, the this thing has evolved. Okay, always remember in the case of humans, this is going to be most advanced or most evolved. Okay, whereas this nerve net, it is the least evolved. This is only your nerve cord, whereas this is nerve ring plus nerve cord. Okay, fine. But now let's try to see this thing, guys. Okay, now the next thing, okay, out over here. Okay, now this is the most important thing, guys. Okay, and before you start with your chapter, studying anything regarding the chapter, guys, you need to know this chart absolutely properly. Without this chart, you are nowhere in this chapter. Okay, so once again, let's try to see what are we really talking about. So guys, when we talk about your nervous system is technically divided into two parts. Okay, so what is it? The first thing, it is your central nervous system. Okay, central nervous system meaning this is the main thing, the heart and the soul of the nervous system. And then the second thing is your peripheral nervous system. Okay, so central nervous system and peripheral nervous system. What is peripheral nervous system? We'll talk about it. First, let's try to have a look at your central nervous system. Okay, so guys, the central nervous system, this is further going to be divided into two more parts. And what is that? This is going to be your brain, and the second one, this is spinal cord. So the brain and the spinal cord. Okay, but now let's try to talk about the brain a little bit, guys. Okay, so let's imagine we have थोड़ा सा नीचे कर देता हूँ. Okay, so let's say we have our brain something like this. Okay, but now what are the parts of the brain? What are we really looking at? So guys, the first one, this is the largest part of the brain. What is this? This is nothing but our cerebrum. This is our cerebrum. Now, below the cerebrum, hanging a little below, guys, this is the small part of the brain. What is this? This is cerebellum. So we have cerebrum, second we have cerebellum. And guys, after this, if you can see this inverted triangle-ish kind of thing, okay, inverted triangle, this is actually your medulla oblongata. Guys, always remember, medulla oblongata is one of the most important parts. Why? Because it controls beating of the heart, respiration, and peristalsis. If by any chance there is any damage to the medulla oblongata, guys, immediately the person is going to die. Okay, I will tell you a small story. Just give me a couple of moments. Okay, and guys, now what happens is this medulla oblongata. See, later on it is going to extend downward like this, right? So when it extends downward, the same medulla oblongata, guys, this is now going to give rise to your spinal cord. This is now going to give rise to spinal cord, guys. And this is how it is going to work. Everybody okay with this thing? Sure. Okay. Now I will tell you one small story that had happened. Guys, you know where I live. Okay. So in Goregaon, the lane in which, okay, there is one building out over there. So it's Rajaram Smruti, the name of the building is. Okay, so what happened was one fine day, there was this guy who was going out for work. Okay, so, he just stepped out of his building. Again, he was just about to cross the road. And in that time, what happened was a guy on a bike, okay, he just speeded his bike and he just, moved swish right in front of him. Okay, he just moved right in front of him, like, speeding really, really fast. Okay, now what happened, guys? The guy who was going for work, he just shouted out to him, कि, "अरे कैसा चला रहा है क्या दिखता नहीं है क्या?" And this. So now the person who was on the bike, he got offended. He started hurling abuses. Okay. Now what happened? This guy, okay, the guy who was going to work, okay, that guy and the other guy, they started having a fight. Okay, verbal fight. Okay, so both of them were like, abusing one another. बहुत झगड़ा हो गया, बहुत झगड़ा हो गया. Now what happened, guys? The fight was so heated up that the guy who was there on on the bike, he removed his helmet and he just hit the other guy onto the head. Bad. And he hit him onto the backside. The moment he hit him onto the backside, guys, the guy who was going for work, he just fell down flat onto the ground. And the moment he fell down, guys, the guy on the bike, he knew that, something is wrong. He picked that guy and he took him to the hospital. But the moment he was brought to the hospital, he was declared dead. Now, the guy who was on the bike, he is in jail for murder. What happened out over there? So when he took his helmet and he hit him onto the head, he actually hit him onto the medulla oblongata, guys. And what happened was, by mistake, his medulla oblongata, it got fractured. Now, as medulla oblongata is responsible for respiration, beating of the heart, and peristalsis, immediately these functions stopped. His heart stopped. Kachak, the guy died. So that way. So this is how it is going to work. So always remember, guys, never hit anybody on the back of the head. Okay. In fact, we also say that, उधर मारने का नहीं छोटा बिंदु होता है, छोटा बिंदु होता है. So something of that. So always keep it in mind. Delicate parts. Okay, so we have the brain, and from the brain we are going to have the spinal cord coming down. All right, so this is your central nervous system. Okay, but now let's try to move ahead and let's try to see what is your peripheral nervous system. So guys, when we talk about the peripheral nervous system, this is the one which is going to include, this includes the nerves which either enter the CNS or leave the CNS. Okay, so which either enter or leave the CNS. Okay, now what happens? Take it, fine. We will see how it is going to work. Okay, but now let's see this peripheral nervous system. This is also further divided into your two more parts. Okay, depending upon how they are going to function. So we have somatic nervous system and we have autonomic nervous system. Somatic nervous system and autonomic nervous system. Okay, but now what is this somatic nervous system going to do? Guys, somatic nervous system, this controls all the voluntary activities. It controls all the voluntary activities. And autonomic nervous system, guys, this controls all the involuntary. It controls all the involuntary activities of the body. Okay, but now when we talk about autonomic nervous system, guys, autonomic nervous system, this includes, see, I said it is going to include the nerves. Okay, but autonomic nervous system, it includes nerves. Yes. But the second thing that it is also include is it is also going to include ganglia. Okay, so what is this ganglia? See guys, so whenever we talk about your nerves, so nerves are going to be made up of your what? It is going to be made up of your axons. Okay, so let's say you have your axons like this. Okay, now we have these axons, guys. collection of your axons is going to be your nerve. Okay, so let's say this is enclosed in a tubular medullary shape. Then this entire thing, okay, this entire thing, this is your nerve. Okay, but now see the cytons, they have to be somewhere. The cytons need to be somewhere, guys, right? So what happens is somewhere away from the nerve, you are going to see that the cytons, they are all grouped together. They are all grouped together in a small bead-like structure or a ball-like structure. And what is this ball-like structure? This is nothing but your ganglia. So what is ganglia, guys? Ganglia, if I have to say, this is nothing but this is collection of cytons. This is collection of your cytons. Okay, everybody all right with this thing? Getting this part, guys, properly? Okay, so now let's get back out over here. So once again, guys, we are going to go into your somatic nervous system. But now, somatic nervous system, guys, somatic nervous system is further going to be divided into two parts. Okay, and what are the two parts, guys? So we are going to have one that is going to be your cranial nerves. We have cranial nerves, and the second, guys, we are going to have spinal nerves. So the cranial nerves and spinal nerves. And now, guys, what happens? Let's try to see. See, as the name suggests, okay, cranial nerves, where are they going to arise from? These are the ones which arise from the brain. Simple. Okay, that is why we have cranial nerves. So let me just show you guys. So let's say this is our brain. And once again, this is our spinal cord, because medulla oblongata is ultimately going to give rise to spinal cord. Okay, and this is your cerebellum. Now what happens, guys? There are going to be some nerves which are going to just arise from the brain, just like that, guys. Okay, something of this sort. These are the ones who are going to be your cranial nerves. And guys, how many pairs of nerve are we really talking about? We are talking about 12 pairs of cranial nerves. Now, guys, 12 pairs means what? 12 on one side each. Okay, meaning 12 on one side, left side, 12 on the right side. So therefore, it is going to be total, if you have to say total, it is going to be your 24 nerves that way. Okay, but now we have the spinal cord, and now from the spinal cord also you are going to see certain nerves coming out. Okay, and now you are going to see that these nerves which come out from the spinal cord, now these are going to be nothing but our spinal nerves, and we have 31 pair of spinal nerve, guys. Okay, like this. And what you will also see that they are going to show you ganglia. Okay, so the ganglia is going to be present like this, like this. Okay, these are ganglia. So guys, first of all, 31 on each side. Yes, yes, yes. 31 on each side. 31 pairs. That is why I said 31 pairs. Okay, so now you are going to see that these are the ones which arise from the spinal cord. That is why we said spinal nerves. And now how many we said? We are going to see we have 31 pairs. So guys, how many in total? So total 62. Okay, so guys, if we look at your entire nervous system, how many total nerves are we going to have? Total nerves that control your entire body, guys, we have 24 plus 62. That is nothing but 86 nerves only. Your entire body runs on these 86 nerves. Okay, got this part properly, guys? Fine. Okay, chalo. But now let's try to move on to the next part. Okay, so next part we have autonomic nervous system. Okay, now autonomic nervous system, what did I tell you, guys? This is going to control all the involuntary activities of the body. Okay, but now if you're talking about all the involuntary activities, guys, once again, autonomic nervous system is going to be divided into two parts. So we have sympathetic nervous system Okay, sympathetic nervous system, and we have parasympathetic nervous system. Okay, so let's try to understand the difference between the two, sympathetic nervous system and the parasympathetic nervous system. Now, sympathetic nervous system, guys, what is the problem with this? I mean, what do we need to know with this thing, guys? The sympathetic nervous system, always remember, this is the one which excites the body. Okay, this is the one which is going to excite the body, meaning it is going to make you suddenly angry. Okay, so it makes you angry, it gives you fear, all those emotions. Okay, sudden emotions, these are given by your sympathetic nervous system. So whether it is being angry, or whether it is fear, or whether this is anxiety, or whether this is fight, all these things is going to be provided by sympathetic nervous system. And guys, now always remember, sympathetic nervous system, this is going to be influenced by adrenaline. Because guys, see, fear, flight, fight, anxiety, all these things, they are nothing but given by your this thing only, your adrenaline. If you remember, we had done the effects of adrenaline, so it is going to be that. So yes, this is going to be influenced. Okay, the sympathetic nervous system, it is influenced by adrenaline. Okay, but now let's try to see the other side, parasympathetic nervous system. Now, guys, once you are angry, okay, once you are angry, are you going to stay like angry young man for the rest of your life? Absolutely no. You have to calm down, right? So that calming down time may be different for different people. So for example, guys, let's say, we are talking about males. Okay, males, they are not going to require much amount of time to calm down. Okay, 5 minutes, and then they are like, the gussa is where they even don't know. Okay, everything is calm down. Once again, they are friends with the other person, and once again, they go hand in hand together that way. But for females, guys, things are really different. Females, when they are going to be angry, they will keep it in their minds for years and years. Then one fine day they will be like, बचपन में तूने मेरे साथ ऐसा किया था. And guys, you are clueless. But then it happens. For females, it works something differently. Males, it works something really differently, guys. Okay. But anyways, so once you are angry, guys, once you are angry, are you going to stay angry throughout your entire life? No. You need to calm down. So there has to be a system who's going to calm your body down. So who is that? The parasympathetic nervous system. So the parasympathetic nervous system, this is the one which calms the body and brings it back to normal. Okay. And now, guys, what is this going to be influenced by? This is the one which is going to be influenced by acetylcholine. Guys, this is the most important neurotransmitter. Same way, guys, adrenaline is going to act as both. Adrenaline acts as your neurotransmitter as well as your hormone. Okay, but guys, you need to remember both of these properly. Who is going to be influenced by who? Okay, so guys, just have a look. So before you start off with the chapter, guys, you need to know this chart absolutely properly. Then only you will remember where we are heading, what is really happening, which part are we going to we are going to do it. Okay, so guys, just have a look at this thing, just see if you guys are okay. If anybody has any doubts, you can ask quickly. Okay, everybody all right? Okay, chalo. So guys, let's try to move ahead. Okay, okay. Acha, okay. Guys, 5 minutes break. Anybody who wants to go to the loo and come back or have water, come back in 5 minutes. Okay, we'll start in 5 minutes. Okay, guys, chalo. So let's start. Guys, once again, if anybody has any doubts regarding this, just ask me quickly right now, or else we'll just move ahead. Okay, chalo. So guys, the next thing that we're going to see is the structure of your entire neuron. So how is this neuron really going to look like? What really happens out over there? So that. Okay, so now guys, when we talk about the structure of neuron, what is the first thing that we are going to see? That it is going to be something like a star-shaped body. Okay, so let's imagine we have, okay, so let's imagine we have this star-shaped body. This is like a magic wand kind of a thing. Okay, and then you are now going to see that this body, this is now going to extend down like this. Okay, something of this sort. Okay, something of this sort. Okay, so one second, let's try to see what are the different parts and all. Okay, so guys, the first thing, this star-shaped body, right inside it, we are going to see a very nice large nucleus. Okay, so we have this nucleus. Yes. Okay. Okay, but now, you know what, guys? What is this entire starship body called? So this entire starship body, this is nothing but your cyton. Okay, so this entire thing, guys, this is our cyton. Okay, but now what is the cyton also known as? Guys, we also call this thing as soma, or we call this thing as body, or we also call this thing as perikaryon. Okay, soma, body, or perikaryon. Okay, so this is the first thing. Inside the cytosol, what are we going to see, guys? We are going to see the nucleus, and then we are going to have the cytoplasm, right? But now in the cytoplasm of this thing, guys, what are we going to see? We are going to see certain granules. Now, generally, guys, when we talk about granules, what are the granules are responsible for? They are responsible for storing your food, right? But here, these granules, they are different, guys. What are these granules called? These granules are known as Nissel's granules. Okay, and these Nissel's granules, guys, they are different. They are going to contain large amounts of your RNA, and because they have RNA, what are they going to help in? They help in your protein synthesis. They help in protein synthesis, guys. Okay, so that is what is going to happen. Okay, fine. But now let's try to see. So guys, on the top side, okay, so see, we can see these points, 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 points. Now, what are these points called? These points, guys, these are called as your dendrons. These points are known as dendrons. Okay, so we have one cyton, then points are dendrons, and from these points, guys, we are now going to have the next thing, that is we have these hair-like structures coming out from there, like this. Okay, so these are some network kind of thing present. So what are these, guys? These are nothing but we call them as dendrites. So we have dendrons, we have dendrites, and we have the Nissel's granules. Okay, so I will just put this thing up. Okay, so these are going to be your dendrites. Okay, fine. Okay, but now, guys, the next thing after this, okay, see, we are seeing that there are these cytoplasmic projections, okay, and these are like small cytoplasmic projection, but one of them is going to be really long like this. So what is this longest cytoplasmic projection called? This entire longest cytoplasmic projection, guys, this is nothing but this is going to be your axon. This is going to be your axon. Or guys, the other name, now keep this thing in mind, guys, this is also known as axon fiber, or we also call this thing as nerve fiber. Okay, so guys, whatever term you use, okay, mainly we will use axon, or the other term that you will use is your nerve fiber. Okay, but now guys, this entire axon, it is not going to be naked like this. We need to cover it with something. Okay, so let's try to see what are the parts out over here. But before that, see guys, see, this is going to be a little transition phase between your cyton and the axon. So guys, this thing, okay, this transition phase, okay, which is going to be between the cyton and the axon, we call this thing as axon hillock. Okay, so very, very, very important. This is known as axon hillock. Okay, always asked in your exams, guys. And then you will see that the axon is going to start like this. But now, when we talk about the axon, guys, now what are you going to see? The axon is going to be covered in a sheet. Okay, and this sheet, guys, what is this sheet? This is called as neurolemma. Okay, now remember, this is not that the myelin sheet that you're thinking of. Okay, this is going to be another sheet. So let me just show you like this. Okay, so what is this, guys? This is nothing but neurolemma. Okay, now neurolemma, or you can also call this thing as neurolemma. Okay, so guys, both the terms are used, whether neurolemma you want to call it, or whether you want to call it as neurolemma. Okay, what is this? This is nothing but it is like a jacket. Okay, this is going to be a jacket which is going to be present on the top of your axon. Okay, just to give it a little bit of protection that way. Okay, but inside this neurolemma, guys, now what are you encounter? You are going to encounter certain cells. Okay, so you will see that, oh, we have these cells which are like this. What are these cells? These cells are nothing but your Schwann cells. Guys, once again, who is this Schwann? The same guy from the cell theory, Theodor Schwann. If you remember, Theodor Schwann and Matthias Schleiden. Okay, so, and the third guy was your Rudolf Virchow. Okay, anyways, but now, guys, inside this, what are we going to see? We have these cells. These cells, these are known as our Schwann cells. Okay, but now, guys, what is the Schwann cell going to do? Wherever the Schwann cells are present, only at that point you are going to see a fatty sheath being produced. Okay, only at that place we are going to have this fatty sheath like this. Okay, so now what is this fatty sheath called? This is nothing but our myelin sheath. Okay, but guys, always keep this in mind. Myelin sheath is going to be present only where the Schwann cells are present. So wherever the Schwann cells are absent, see here in these regions, there is going to be no myelin sheath. Okay, always remember this thing. Okay, so I'll just mention out over here. So this is going to be myelin sheath. Okay, but what is this myelin sheath made up of? Myelin sheath is made up of nothing but your phospholipids plus your sphingomycin. Sphingomyelins. Okay. Sphingomyelins. Always remember. Okay, in your exams, guys, they ask you this thing. Okay, what is the composition of myelin sheath? So phospholipids plus sphingomyelin. Okay, but now, guys, I told you, see, there are going to be these places where The myelin sheath is going to be absent. So what are these places called? These places, guys, we call them as nodes of Ranvier. They are known as nodes of Ranvier. Okay, and why are they actually present, guys? Actually, the electric impulses, they jump from one neuron to the other neuron, and they will be jumping from one of this. So it will jump like this, like this, like this, guys. Okay, so it is going to help in faster conduction of impulse. We call it as your saltatory conduction. Okay, fine. Okay, now once this thing is done, guys, now what are we going to see? We are going to see here. Okay, so we are going to have the axon. The axon is going to come down and ultimately it is now going to branch. It is going to branch into different branches like this. Okay, what are these branches? These are called as your axon terminals. Okay, these are known as axon terminals because ultimately they're going to end into something. Okay, what are these going to end into, guys? They are going to end into these bulb-like structures. So we call these bulb-like structure as your axon bulbs. Okay, you can call them as axon bulbs, or we also call them as telodendrons. Okay, axon bulbs or telodendrons. Okay, and now what are we going to see, guys? In the telodendrons, we are going to see that, oh, you are going to have these neurotransmitters being present like this. So these are neurotransmitters, guys. Okay, and once again, who are our neurotransmitters? Let's try to see. So two of them we have already spoken of. So I'll just put down the first two. So we said we are going to have adrenaline. I told you adrenaline. This is going to influence your sympathetic nervous system. Once again, always remember, guys, adrenaline is the one, okay, which is going to like excite your body, make you angry. Okay. Also, it is going to be your hormone, but at the same time, it also acts as your neurotransmitter. So dual function. Okay. Next thing, after the adrenaline, guys, we said, okay, it is going to be your acetylcholine. Okay, fine. Then what? Then we have dopamine. We have GABA, gamma aminobutyric acid. Then we have serotonin. Guys, these are all something like, some of your, important neurotransmitters. Okay. So guys, this is the structure. Okay, this is the structure of your one single neuron. Guys, just see if you're okay with this thing. Then we still have to talk about like, how is it going to be connected to the other neuron? Like what really happens out over there? Okay, but before we move ahead, kindly go through this thing. Just see if you are okay with this. Cyton is that star-shaped body. The star-shaped central body is your cyton. See this, whatever we have drawn, this is your cyton. Okay, chalo. So everybody okay? Anybody else wishes to ask anything? Sure, no issues. Okay. Now let's try to move ahead and let's try to see the next part, guys. Okay. So now what happens, guys? See, in your body, there are going to be hundreds and hundreds of neurons which are going to be linked one after the other. Okay. And now you need to pass the information from one neuron to the other neuron. So how is it really going to happen that way? Okay, what really goes on? So let's try to see, guys. So guys, when we talk about your axons are not really connected to one another. Okay, they are not really connected to one another, like, physically. But in between them, there are going to be certain spaces. Okay, you will see that there is some space present between the first neuron and the second neuron. Okay, so let's say I'm drawing the second neuron. It is something of this sort. Okay, something like this. Okay, so now what happens, guys, is, let me just copy this thing. Okay. So guys, in between two consecutive neurons, there is going to be a lot of space. And what is this space called, guys? This space, it is known as synapse. This space is known as synapse. So what happens? Let me just tell you, guys. Okay, so in the first case, when the impulse has to pass, okay, the information has to pass, the information will pass from the dendrite to the dendron, from the dendron to the cyton to the entire length of the axon. Then ultimately it is going to enter into your axon branches or axon terminals. Then it is going to enter into your axon bulbs. The moment it enters into the axon bulbs, now what happens, the axon bulb vesicles, okay, there are some vesicles inside which are containing the neurotransmitters. They come up to the surface of the axon bulb. And now what? When they come to the surface of the axon bulb, now you are going to see they release their neurotransmitters out over here in the gap. Now, the moment the neurotransmitters are released in the gap, now what is going to happen, guys? Immediately, you're going to see that there is a connection which is going to be established between the first neuron and the second neuron. And now what? That impulse is now going to jump from here into the second neuron. That way. Okay, now let's try to see. But now see, if this connection is completed, if this connection is going to be complete like this, then the impulse will keep on passing like that every now and then, again and again, again and again, again and again, right? So what we need to do is, in order to avoid that, continuous impulse, I need to remove this the neurotransmitter from here. So how am I going to remove it? So guys, there is going to be an enzyme. Okay, so for example, like let's say, guys, we are talking about acetylcholine. So here acetylcholine is released. Now, in order to clear of this acetylcholine, guys, we are going to have an enzyme who's going to come over here. What is this acetylcholine, guys? The enzyme which is going to remove this thing, it is known as cholinesterase. Cholinesterase. Now, what is this going to do? This is going to come out over there and it clears the synapse. It clears of the synapse. So now you are going to see that, oh, it is going to come and it is going to just erase this entire portion, guys. So once this portion has been erased, now what happens? Now the synapse is ready for its next impulse. And once again, the same thing, then the next impulse is going to come. It is going to help release the neurotransmitters. Neurotransmitters will come up into this space. And then what? Cholinesterase once again will come and it is going to erase off that entire synapse. That way, this is how your impulse transmission is going to be like, guys. Always remember, impulse is going to be transmitted only in one direction. Okay, I will just mention out over here. So impulse, it moves only and only in one direction. Okay, and how is this? First, it is going to be from the dendrites. From the dendrites, it goes to the dendrons. From the dendrons, it goes to the cyton. From the cyton, it goes to the axon. From the axon, it goes to the axon branches. And from your axon branches, it is now going to go into your axon bulbs or your telodendrons. This is the flow. And finally, it is going to land up into your synapse. Okay, now this is the entire flow or conduction of your impulses, guys. Everybody okay with this? Fine. Understood this part properly, guys? Okay, but now the next thing, guys, okay, the next thing I also want to show you. Okay, now when we talk about your neuron, okay, guys, now what happens is sometimes the neuron is going to show you branches. So for example, from here, from this axon, guys, from the nodes of Ranvier, you may see one more branch coming out like that. Okay, so one more branch, it just comes out. And now you are going to see that, oh, okay. It is like this. So what is this? This is called as your collateral. This is known as collateral, guys. Okay. Now, one more thing, very important. Okay, that is your neurons, they do not multiply at all. Okay, neurons, they never multiply. And why do they don't multiply, guys? Why don't they multiply? They don't multiply because they lack centrioles. Huh? Go? Where go? Huh. Okay. Okay, so these are the ones, they are going to lack the centrioles. And guys, because they lack centrioles, they are never going to divide. So never multiply, they never divide, they never regenerate, guys. Okay, always keep it in mind. So why does it happen? Okay, why does it happen that, uh, even if the centrioles are not present, why will they not multiply? The reason is, guys, when we talk about the centrosome itself is required for initiation and regulation of cell division. Now, if centrosome is not there, then will the centrioles be there? No. And if the centrioles are not there, then will the initiation of cell division take place? No. So that is why you're going to say that. Okay, then how does almond affects our brain because neurons are not regenerating? No, it is just going to help you boost your memory. It is not going to help you increase the number of neurons as such. Okay, so it is just going to help you in memory, like boosting your memory. Same way, walnuts are also. Now, what is the belief behind it? Okay, if you look at the walnut also looks like your brain. So we feel that, oh, whatever that looks like your brain, if you have it, it is going to have effect on the brain. That is the idea behind it, nothing else. Okay, so guys, this is what we need to know with regards to the first part, okay, about your neurons and all that stuff. Okay, but now let me just quickly pull out a picture and let me just show you, guys. So see, in your normal, okay, when you look into a microscope, guys, you will see that, oh, this is that neuron. Okay, it appears somewhat like this. Okay, and now we have, see, I told you in between there are going to be these neuroglial cells. So see, these are our neuroglial cells, guys. Okay, these are nothing but we see these are our packing cells. Okay, so that way. So this is what we need to know with regards to the first part, guys. Okay, also remember, guys, this neuroglial cells or glial cells, they are very important because they also show you phagocytosis and they help protect your brain. Okay, so from any kind of infections and all. So they're like really important. Sir, but does it help like walnuts and almonds? Yes, it is believed it helps. Okay, now it is not necessary that it will always help because I have a few friends who have been eating walnuts right since their childhood times, but still their memory is not so good. Okay, so it is just a myth kind of thing. It is not really, really, really going to help you that way. Just a myth. Okay, chalo. But now let's try to see the next thing, guys. Okay, so now the next thing we are going to talk about, guys, we are going to move into, yes, 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 even badam also. Okay, I'll tell you, one of my friends, she has almonds every day. Okay, even now, but then she cannot remember what really happened 2 days ago or 3 days ago. In fact, she forgets what she had said, like maybe like a week ago or 2 weeks ago also. So I don't know whether this thing really works or not. Anyways, so guys, now what are we going to do? We are going to go into your CNS. CNS, that is central nervous system. We said central nervous system. What is it going to be divided into? Two parts. We have the brain and we have the spinal cord. So first thing, guys, we are going to go into the brain, and now we are going to see what is this brain, where is it going to be, how is it going to be located, what do we really need to know. So guys, the first thing we need to know is we are going to have our skull. Okay, so let's imagine this is our skull, something of this sort. Okay, so from the side views, the skull may look something like this. Okay, now inside the skull, guys, what are we going to see? We are going to have a brain box. Okay, now what is this brain box called, guys? This is nothing but your cranium. This is called as cranium, or we call this thing as the brain box. Okay, but now inside this cranium, guys, what are we going to see? We are going to see that inside this brain box, now you are going to have the brain being loaded that way, this way, guys. Okay, now guys, why is this going to be that way? Because you need to provide protection to the brain. Otherwise, what will happen, guys? The brain is semi-solid. It is semi-solid, jelly-like kind of thing. If there was no protection, the brain would have kept bouncing off the skull, right? And then it would be really, really difficult to maintain it. So it needs to be fitted into the box so that now it can be like, properly housed, and it can be like properly safe that way. Now, guys, you know what? If you know the Egyptians, okay, the Egyptians used to mummify the dead bodies. So what used to happen, guys, they used to remove all the internal organs. Same way, like when we talked about your pituitary also. Okay, so what happens is they used to take a hook and they used to poke it through the nose. And as they used to poke it through the nose, they're going to pierce through the cranium. Guys, now once the hook was inside, now they used to swirl that hook. Like, how you roll noodles onto your fork, the same way. And then they used to pull it out. The moment they used to pull it out, all the brain and everything used to come out through the nose. That is how they used to do it, guys. Okay, anyways, so now first of all, guys, when we talk about brain, what is we are talking about what is the weight of the brain. So guys, if you look at the weight, it is going to be roughly around 1300 to 1400 grams. Okay, 1.3 to 1.4 kg. Guys, remember, this is almost at par with your liver. Liver is also 1.5 kg. Okay, so same thing of that sort. Okay, 1300 to 1400 grams. Okay, so basically this is also going to be like, if you calculate this thing, so this is going to be 1300 to 1500 cc volume. 1300 to 1400 cc volume, guys. And when we look at this, from where does this thing come and how is it going to be made? When is it going to be completed? Guys, the development of the brain, this is completed by 6 years. Okay, this is totally completed by 6 years. Okay, fine. But now let's try to see what is the protection that is provided to the brain. Okay, so first thing, guys, first thing, how is the protection provided? The protection is provided by the skull. Second thing, it is going to be by the cranium or the brain box. Third thing, guys, third thing, it is going to be given by your meninges. Now, guys, what are the meninges? Meninges are nothing but the coverings of the brain. Okay, singular, if you look at it, singular, we call this thing as meninx. Plural is meninges. Okay, but now what are these meninges? How are they going to be present? What really happens? Let's try to see. Okay, so let's try to quickly see this thing. Okay, so guys, once again, we have our brain. So let's imagine I am drawing your brain like this. Okay, now you are going to see that covering this brain, there are going to be three more layers, okay, from outside to inside. So I'm just drawing this. Now, there is not so much of space, guys, okay? There is not so much of space, but I'm just drawing it for understanding purposes. Okay, so guys, what is this thing called? The first one, which is going to be on the outermost side, guys, that is known as dura mater. Okay, now what is this mater? Mater meaning mother, alma mater. Okay, that is your school is your alma mater. Okay, now why do we call it as mater? Mater meaning, guys, this is the one which is going to provide protection. Mother is the one who's always going to provide protection to the baby. So same way, dura mater is going to provide protection to the brain. That is why mater. Okay, but now how is this? You are going to see that this is going to be really, really tough. This is going to be fibrous. Okay, this is tough. Sorry, it is fibrous. Okay, next, this is going to be protective in function. And how is it, guys? It is going to be attached to the inner lining of the cranium. It is attached to inner lining of the cranium. That is how your dura mater is going to be like, guys. That's it. First thing. Okay. But now, guys, after your dura mater, we are going to have the second region. Okay, this second region, this is going to be a web like cushion. Okay, so it is like soft, it is web like it, it's something like that. Just a moment. Okay, so what is this second region called, guys? This second region, this is called as your arachnoid membrane. Okay, so we have this arachnoid membrane. Okay, but now see, there is this space between your dura mater and arachnoid membrane. See this space, right? See this entire thing. Can I say this is below your dura mater, right? So because this is going to be below the dura mater, guys, we call this thing as your subdural space. This is our subdural space. And guys, this subdural space, what is this filled with? This is filled with your serous fluid. Okay, so let me just show it this way. Okay, so guys, sorry, इधर लिखा है ना. So this is subdural space. And what is this filled with, guys? This is going to contain your serous fluid. Okay, fine. Chalo. But now let's try to move ahead. Okay, so now the second thing we said that this is going to be a arachnoid membrane. I told you this is going to be a web-like cushion. Okay, now how is it? Now always remember, guys, this is going to be slightly vascular, meaning it is going to show you the presence of your blood vessel. And why is it that way, guys? Because it needs to provide nutrition. So first, because so that all the cells get proper amounts of nourishment, so it provides nutrition. And lastly, because it is going to be a membrane like structure, guys, what is the other job? This is the one which is going to provide protection. Okay. So that way it provides protection. Okay, fine. But now, guys, after this, let's try to see after your arachnoid membrane, once again there is going to be this space, right? Now, guys, this space is called as your subarachnoid space. Okay, so this space, whatever that is there, this is subarachnoid space. Okay, but now what is this subarachnoid space filled with? So guys, this is also going to be filled with a fluid. And what fluid are we talking about, guys? This is nothing but your CSF, cerebrospinal fluid. Okay, so this is filled with cerebro CSF. Okay, fine. Okay, but now, guys, now after this, we are going to have the third region. Okay. Acha, first of all, guys, is everybody okay until this point? Has everybody understood? Is there anything you wish to ask until now? Ah, yes, go ahead, please. What is the cranium part? Cranium part is, see, what happens now? If you open up the skull, so let's imagine this is the skull. Let's say I have opened up. Okay, you will see that there is a box-like structure, meaning an empty space. Acha, if you are having trouble understanding that, then let me just pull out a picture of cranium. Wait, maybe that will help. One minute, just give me a moment. Okay, so now let me just show you. See, we had done this thing when we were talking about your skeleton. Okay, so when we talked about skeleton, we had talked about the cranial bones and all, right? So see, once again, the same thing. Okay, see, we have all these bones. Okay, the parietal bone, the frontal bone, the ethmoid bone, temporal sphenoid, all of them, they are going to form a cavity in the inside. and that cavity is going to be a box-like structure. That box-like structure is going to be your cranium. So let me just show you another one. See, if you cut it open, okay, if you cut open, then see, you are going to see that, oh, this is that entire box like thing which is being formed, where the brain is going to be present. This is your cranium. Okay, I hope this is okay with you now. Fine. Yeah. Okay, chalo. So now guys, the third thing after this. Okay, so what are we going to have? See, the third one, okay, which is going to be, just a second, guys, just a second. Okay, so now guys, now what is going to happen is the third region. Okay, so this is the third thing which is going to be hugging the brain. Okay, so keep this in mind. This is just hugging the actual brain. This is the third region. So what is this third region, guys? This is going to be your pia mater. Okay, so remember this thing, the third one out over here. This is your pia mater. Okay. Now, one thing that we need to know about the pia mater, guys, this is going to be highly vascular. Highly vascular. And second thing, once again, because this is vascular, guys, what is this going to do? It is going to provide a nourishment. So provides nutrition or nourishment. Okay, fine. So this is how all the three things are going to be present, guys. Is everybody okay with this thing? Sure, no problem with this, guys. Okay, always remember in your exams, okay, guys, very important. They will ask you what is the location of your cerebrospinal fluid. Now, guys, traditionally, we have just said that, cerebrospinal fluid is going to be present in between the meninges. No, but here you need to be very sure that it is going to be present only in the subarachnoid space. Guys, you need to know this thing properly. Otherwise, you will be marked wrong. Okay, if you just write in between the meninges, it is wrong. Okay, but now, okay, so guys, how I have shown it out over here. Okay, now let me just show you one picture. Who is going to show you the meninges together? Okay, so see, guys, so these are the meninges. I told you there is not going to be much amount of space. What I'm showing you is only for your diameter and understanding purposes. So guys, see, until here, this is the skull, guys. Okay, so here, this is your entire skull. Okay, and now let's try to see. So first one, dura mater. Okay, so I told you on the outside it is going to be dura mater. So see, this is dura mater. Second one, we have this web-like structure. So see, can you see this web-like structure? So this is going to be your arachnoid membrane. And third thing, which is going to be behind that. Okay, so this one, that is going to be your pia mater. So that way, so dura mater, arachnoid membrane, and pia mater. This is how it is going to be like, guys. Okay, all right with this thing, fine. But now, guys, sometimes what happens, you are going to have inflammation of your meninges. Then what do you call this? So let me just show you. Okay, so inflammation of one meninges. Sometimes by mistake, okay. So by mistake, what may happen, you may have swelling and all taking place. maybe because of some infection. Very day. Okay, because of some infection, or it can also happen because of some kind of an accident or trauma to the head. Now, what is this inflammation of meninges called, guys? This is nothing but we call this thing as meningitis. This is known as meningitis, guys. Okay, and if by any chance there is inflammation of the brain, then what do we call this thing? We call this thing as encephalitis. Keep this thing in mind, guys. Okay, so that way. Okay, everybody all right? But now, see, guys, we said that, below the arachnoid membrane, we are going to see the CSF. So what is the CSF? And what are the functions of CSF? Let's try to see. Okay, so we are saying we have your CSF, cerebrospinal fluid. And now this cerebrospinal fluid, guys, roughly this is going to be 120 ml. This is also going to be slightly alkaline, guys. Very, very important. You will be tempted to say this is acidic, but no, this is slightly alkaline. And guys, who is going to produce this thing? See, I told you, see, we had the ependymal cells, right? So ependymal cells, yes. But this is produced by two things. Okay, produced by one, we have the ependymal cells, those are there. And the second thing, we are also going to have your anterior choroid plexus. Anterior choroid plexus. So both of them, anterior choroid plexus, we'll talk about this thing when we talk about the structure of the brain. Then you'll come to know what exactly is the anterior choroid plexus. Okay, but now what is the function? Let's try to see why are we producing this CSF in the first place. So let's figure down the functions. Okay, so first of all, guys, as we have already stated, this is the one which provides nourishment. Okay. Second thing, guys, this is the one which is going to provide oxygen. This is very, very important, guys. It provides oxygen. Okay. Third thing, this is the one which prevents friction between the meninges because I don't want, wear and tear between the meninges, right? So prevents friction. Okay. Next thing, next it is going to maintain. Okay. It is going to act as a shock absorber. It is going to act as a shock absorber so that if by any chance there is any kind of force or any kind of shock onto the brain, it is going to take it away and prevent the brain from being affected. So acts as a shock absorber. And same way, guys, I can also say this protects the brain from jerks or mechanical injuries. Okay, fine. Next thing, guys, we have, okay, this is the one which is also going to maintain equal pressure on the brain so that the development is proper. Okay, otherwise, what would happen? One part would increase more in size, other part would be a little less in size. That would be a little troublesome. So it maintains equal pressure on the brain. Okay, and next thing, guys, this is the one which also removes nitrogenous waste. Okay, and finally, this also helps in regulating temperature because this is like continuously moving up and down, up and down, up and down. So it regulates temperature of the brain and the spinal cord. Okay. Oh, okay, Devank. I have no idea about it. uh, what are meninges? Meninges are nothing but the coverings. See, this meninges, see, you have the brain, see, you have the normal brain, okay, and this brain, I cannot leave it open, okay, because then it will be damaged easily, because this is going to be in contact with the skull, the cranium. So in order to protect it, we have this protection. See here, we have already spoken now. See, how is the protection given? The protection is given in three ways: skull, cranium, and meninges. Just to give you once again an idea, let's say this is your brain like this. I want some protection, so you're going to wrap it in different layers, okay, and these layers are nothing but your meninges. This is to give you like the simplest idea. Okay, everybody all right, guys? Just have a look. Just see if you are okay. In your exams, they will always ask you in your NEET exams, okay, how is the arrangement of the this thing, the different meninges. So dura mater, arachnoid membrane, and pia mater. The order needs to remain the same. Okay, so guys, just see if you are okay. Everybody is all right with this. Okay, chalo. So guys, once again, what we'll do, we'll stop over here for the day, guys. And next class, when we come back, we'll move ahead with the structure of the brain. Don't miss the next class, guys, because it is very, very, very important. Okay, chalo. So we'll stop over for the day and I'll see you in the next class. Till then, take care. Bye-bye, everybody. Bye-bye.